Hello everybody, we have an example here. This will be example 1 for chapter 10, and we are looking at a C channel. And if you notice on the figure, I have already drawn two small little lines here, and I've already labeled my parts 1, 2, and 3. So I'm going to go ahead and put those in here. So I got part 1, part 2, and part 3. Now let's look at my table. I have an area, I have IY prime, and I have IX prime. And remember, the IY prime is BH cubed. On the lecture, I called it HB cubed over 12, and IX is BH cubed over 12. That's a B. That's our IY prime and our IX prime. And then we're just adding the area times the distance from the axis that we're looking at to the centroid of each one of those pieces. So let's go through this example and try and get some questions answered. So finding the areas are pretty easy. One is going to be 160 times 40, which you get 6,400. Number 2, you get 120 times 40 is 4,800. And number 3 again is 120 times 40, which is going to be 4,800. IY prime. Now IY prime is HB cubed over 12. So we're looking at number 1. So I have 1/12. Now I'm going to call this my height, which is 40, times my base, which is 160 cubed. And I come up with a big number. Here I'm going to have 1/12 times 120 over 40 cubed. That's section number 2. That's this little piece right here. And then section 3, I'm going to have 1/12 times 40 times 120 cubed. Just using this example. Now dx. Now when I'm looking at dx, so I'm looking at this as my axis down here, my x-axis, all the way down here. So I got to find the distance to here for segment number 1 or part 1, to here for segment number 2, and to here for segment number 3. So dx is going to be, that's dy. dx is going to be, and I apologize, I'm doing y prime first. It's going to be this distance for part 1. Part 2 is going to be this distance, and part 3 is going to be this distance. So it's actually much easier. So if you say half of this rectangle would be 1, of rectangle 1 would be 160 divided by 2, or times 1/2, which would be 80. Here this is going to be 40 times 1/2, which is going to be 20. And here it's going to be 120 times 1/2, which gives me 60. Now, IY is equal to IY prime plus AD squared. So now this is purely calculator. So I'm taking my IY prime, so 1/12 times 40 times 160 cubed, plus 6,400 times 80 squared. I came up with 54.613 times 10 to the 6th. Here, again, one more time, 1/12 times 120 times 40 cubed times 4,800 times 20 squared is 2.56 times 10 to the 6th. And the last one, same equation, I came up with 23.04 times 10 to the 6th. If I sum all those up, my moment of inertia about the y-axis is 80,213,333 inches to the fourth. This is inches to the fourth. So base times height, base inches times inches cubed is inches to the fourth. This here, this piece here is area squared, distance squared, so that's also going to be inches to the fourth. So you can add those. That's dimensional homogeneous if you want to say. So it's going to be inches to the fourth. This is inches, inches to the third, and inches. Now IX. IX, I'm looking at number 1. The base is 160 and my height is 40. So I have 1/12, 160 times my height cubed. I have my answers on this one. I didn't have them on the other one. My apologies. 1/12 times 40 times 120 cubed. That's 5,759,999. I used whole numbers here. 120 times 40 cubed, 640,000. dy. Okay, so this is what I was talking about earlier. So I'm coming from my x-axis. So my dy from my x-axis down here to the center of object or part 1. So I'm going up 200 to the top, and then I got to come down half of that height, which is 20. So 200 minus 20 is going to be 180. Now I go up 200. Now I got to come down half, or I can go up 200 minus 40, and then this distance here was 200 minus was 120. This distance is 120. So I come up with a distance of 100. And then the last one is just the distance to the center from the x-axis, which is half of 40, which is 20. Now again, pure calculator. Here's my equation. 208, 213, 333 million. 53,760,000, 2,560,000. Those are some big numbers. So this was IY, my moment of inertia about the Y, and my moment of inertia about my X is 264,533,333 inches to the fourth. So those would be my two answers. And because I'm cool, I highlight my answers so it's easy for somebody to go and look to see what answer I got. So that's moment of inertia about an x-axis, y-axis, going about that, purely going about the y and x-axis. I'm going to go over the next problem. It's going to be the same C channel, but we're going to have to find the moment or the centroid and then find our moment of inertia about the centroid. Alright, thanks for listening.